Okay, so now that you've got hopefully the big picture view of concurrency and parallelism in general, you understand the different epochs that we have with Java. You know that there's the 1.0 version, the 1.5 version, the 1.7 version, and the 1.8 and beyond versions of Java, and you know a little bit about that stuff. What we're going to do is start diving into the details of the 1.0 stuff. So this is an overview of Java threads. And so we'll be talking here about how Java threads support concurrent processing, where we simultaneously perform these different operations that may or may not interact with each other. For a lot of the concurrency stuff, there will be interactions. It doesn't have to, but there often will be. And we'll talk about our case study app. All the applications that I show here will have fun, interesting case studies, typically written in Android using Java, so you can play around with them and run them if you want to learn more about how this stuff works. So I'll talk about that. I'll talk about different ways of giving code to a thread, which is very useful because that's how you get them to run, and that'll be really important for your first assignment. And then we'll also perhaps have a chance of talking about how to pass parameters to a Java thread as well, which is a little mysterious at first. So what is a thread? A thread in Java is the most basic way of obtaining concurrency. As you'll see, the later stuff, like the parallel streams and the completable futures, shield you from the details of threads. But never fear, threads are being used under the hood to do all that stuff. So threading is very important. So a Java thread, I think I mentioned this before, is basically a unit of computation that runs in the context of a process. So the two concepts that are important here, thread and a process. So a thread is basically a stream of instructions that carries out some task or some operations, and it runs in the context of a process. What is a process, you ask? A process is a unit of resource allocation and protection. So if anybody here has taken the operating systems course, then you're probably very familiar with processes. And a process, say in Linux or Windows, is basically this abstraction that will be protected from other processes by leveraging the memory management unit hardware features and the virtual memory features of an operating system. So they're protected. They can't smash into each other. And a process is also a container, using the word loosely. It's an environment or a vehicle by which we can allocate resources for the app or apps running in that process, in that protected address space. And so some of the resources would be things like, obviously, memory. Some of the resources would be things like threads. Some of the resources would be things like various I/O handles for sockets or files and whatnot. So the process allocates resources and protects the application or applications running inside of it from accidental or malicious attacks from other processes running on that machine. Java enables multiple threads per process, and of course, since you can have multiple processes, you could have multiple threads running in multiple processes. Any given thread will be running in a process. So as you can see here, we've got three processes, process A, B, C. In real life, they'd have more interesting names like process 2751. And in process A, we've got 3 threads. In process B, we have 1 thread. In process C, we have 2 threads. And not surprisingly, you can allocate threads. Every process starts out with a single thread, which is typically called the main thread. And you can add additional threads programmatically, or libraries could add additional threads on your behalf. As we talked about before, Java threads that are in the same process can communicate with each other by either a shared object, where this thread reads or writes something to this object, which this thread can then obtain by reading and writing from that object, typically in a thread-safe way or a synchronized way. Or they can pass messages back and forth. So this thread here could create a message and then pass it over there. And the message is really nothing but a data structure, right? So there's nothing particularly deep about that. It's just a way of communicating events or data structures between the threads. If you are in certain environments, then threads in one process can communicate with threads in other processes, either by inter-process communication, or IPC, and/or by shared memory. Inter-process communication, of course, is always there, and there's lots of different mechanisms you have in Java. You can use things like sockets and other means of IPC. Shared memory is something that's not as widely provided in vanilla Java, but you can get it with other frameworks that that extend Java. So Android, for example, has a shared memory mechanism. Android also has other IPC mechanisms as well. And we'll talk about those Android-centric forms of shared memory and inter-process communication later in the course. So a couple things to remember for like quizzes, what's a process? What's a thread? How do they differ? And I like to think of it sort of in a containment relationship sense. Processes are the environment of allocation and protection in which one or more threads can run. So threads exist within a process. Each Java thread has certain unique state and that it gets from the underlying operating system. This should not say Linux kernel, it should just say the underlying operating system threads. In the Java virtual machine model, the Java abstractions are mapped into typically some operating system like Linux or Windows or VxWorks or whatever. And some of the things in a thread are unique per thread. In other words, every thread has its own set of these things. So those would include stuff like a runtime stack to keep track of the function calls within that thread, an instruction counter to know where you are in the stream of instructions in that computation, in that thread, and other registers, things like thread-specific storage and other information that's specific to the state of a given Java thread. So some things are unique. Other things, however, are common. So some of the state that's used by threads within a process are common to all the threads. So the best examples would be things like memory that's allocated off the heap. So whenever you say new in Java, you say new, new task or new runnable or new this or that. That's going to use the heap, the dynamic memory management mechanisms, to allocate memory. And all that memory is shared between the threads. And so that's how you can pass messages around from one thread to another, because it's all coming out of kind of the global thread pool or memory pool. Other things that are shared would be things like files. So if you have something like a file or a socket that's open, you can share those things. And anything that's a static object could also potentially be shared if you pass the reference around, if it escapes from the environment in which it was created. So those are things that are common. So some state is unique per thread, some state is common per thread. And obviously, for anything that could be common between threads, you have to be very careful about how you access it. That's where synchronization comes in, because you don't want to be sharing something and having different threads read and write to it in a way that will corrupt it. So those are also important things to remember for quizzes. What's shared, what's common, and so on. So with that brief background, and by the way, feel free to jump in anytime you have questions. Let's talk about the case study. Yes? No. In Java, each thread lives within a given process. So that was the question was, can you share a thread across processes? And each thread exists in one process and one process only. However, you can communicate from one thread in one process to another thread in another process using things like inter-process communication, or if you're running on a platform that supports shared memory, you could use shared memory as well. So let's talk about the case study that we'll use to give some meat to this discussion. I always like to anchor the concepts with some concrete code. So this is an app. You can get the app here. And the app, there's lots of different variants of this app, and they all basically do the same thing. They give you a bunch of choices of how to create threads, and then they go ahead and compute the greatest common divisor. So it randomly generates big numbers and then looks for the greatest common divisor of those numbers, and it runs that stuff in parallel. And we're going to talk about how to do this by using various mechanisms. For example, we'll talk about using the runnable interface. We'll talk about using it by inheriting from the thread class. So obviously, if you're going to run a thread, you've got to give the thread some code to run. Hopefully that stands to reason. If you just create a thread and don't give it any computation, it won't do anything. It would be completely useless. So as a result, do not do this. Do not say, thread t equals new thread, open, close, t.start. That will start a thread that does nothing because it has been given no code. And you can read this Stack Overflow article about why anybody would ever want to do something even remotely like this, and it'll explain why. But the basic answer is don't do that for the most part. There's several different ways to give a thread, something to run. One way, which is kind of the most obvious way of doing things, is to simply extend the thread class. Now, I'm assuming that everybody here has worked with Java enough to know what that means. So extending the thread class means that you will make a new class like GCDthread that extends the existing Java class library thread class. And so that's what it looks like. That's just inheritance in Java. If anybody is like massively surprised by that, you may be in the wrong class, because I'm taking that for granted that you guys know how to do that. There's a method called run that's an abstract method that it's a method that needs to be provided by somebody. It actually has a default behavior, but you should think of it as an abstract method. And if you extend thread, then you need to provide the code for the operating environment, the virtual machine, or the execution environment that runs the Java code to run that thread. So what you would do in this case is you'd override the run hook method. You can read about a hook method here and define the computation for the thread. A hook method is just a point of variability that can be called back by a framework. In this case, it's the thread library that's the framework. Here's how we would actually do this. We'd say new GCD thread, which is a GCD thread, and we would say GCD thread.start. In fact, you could actually say thread GCD thread, new GCD thread, thread GCD thread.start. You don't have to say GCD thread. You can just say thread because it's subclassing. So we go ahead and start it, and what that will do, well, that will then run the computation in the GCD thread implementation. You could also write an anonymous one-liner if you want to create a new thread and start it. This would be useful if you just want the thread to run and you don't care about ever joining with it or synchronizing with its completion. So that's one way to do it, extending the thread class. Strangely enough, that's actually not typically the preferred way to do things. Another way to do things is to implement the runnable interface. So there's an interface called runnable, which is a so-called functional interface. It has a single method called run, which takes no parameters and returns no results. So it's pretty simple. And what you do here is you implement the runnable interface, filling in the run method, because it's got a method called run. And that's where you do your thing. That's where you put your computation. And there's a couple of different ways to do this. One way is like this. You could say class GCD runnable implements runnable. You put your code here. You could then say, new GCD runnable, and then you could say new thread, passing in the GCD runnable dot start. So that'll make a new thread. It'll give it this computation to run. It'll start the thread. Away you go. So that's one way to do things. That's a very common way to do things. Another way to do things is to do what's called an anonymous inner class variant. So you go ahead and you say new thread, and then inside the open curly brace of the thread constructor parameter list, you say new runnable, this is an anonymous inner class, and then you define whatever code you want to have, and then you say .start. So this is an anonymous way of doing things. This way of doing things is very, very common in older versions of Java and older versions of Android. So I'm showing it to you. I don't actually like this way of doing things. It's pretty hideously verbose, but it's common, so you have to be familiar with understanding what it looks like. The modern way of doing things, if you're using a version of Java that's 1.8 or later, is to use something called a lambda expression. And a lambda expression is just an unnamed block of code with optional parameters. In this case, there are no parameters because the runnable interface doesn't take any parameters. Instead, you use this interesting syntax. You say open, close, which means no parameters, arrow, and then you can put the code you want to run within the open, close curly braces. So this is a way of being able to have an anonymous block of code that can be passed around. We're actually passing it to the thread constructor, and when we call start, that's the code that will run. And so this works very well for short code where you're not going to be needing to repeat it multiple times. So if you have just very short code, this is a perfectly useful thing to do. If you have very long code, this can get unwieldy and hard to read. Or if you need to reuse the code multiple places, it can be excessive to have to keep retyping it. So you can also do something like this. You can also do something like say, runnable r equal, and then you give your lambda expression here, assigning it to a local variable. And then you could say new thread r dot start or whatever. So this is a way of being able to extract or refactor the code that's shown there, sticking it here. So it's isolated and could be reused, or maybe it's just easier to read, maybe it's easier to comment, whatever. And then you just pass that into the constructor when things start. That's the kind of the new preferred way, especially if you're using Java 8, which is what you'll be doing in this class. All right, the last topic here is how do you pass parameters to a thread? So if you take a look, you can see thread run and runnable run take no parameters. So at first glance, you might think, well, how the heck will I ever get any parameters to a thread? The run method doesn't take any arguments, so what can I do? So it turns out that the answer to that is quite simple, and you just have to think more broadly about object-oriented programming in Java. So whenever you're creating something, you can create an object that has constructors that can be used to pass the parameter to the object, and then that object can be then used to start the thread. And so when the thread starts to run, it'll have its parameters there immediately. So let's take a look at an example. So one way to do this is to have parameters passed to a class constructor. So if you take a look, this is one of the examples from my GCD app. You could say class GCD runnable extends random, so we're going to generate random numbers, implements runnable, so we get the run method. And then we're going to define some fields here, like the main activity or whatever. And then the constructor for GCD runnable can take whatever parameters you want the thread to be able to access, and it'll go ahead and stash them away in the local field. I have a very simple convention where my fields start with M for member. That's just my convention. Then the run method, which is what the thread framework in Java will actually invoke once the thread is ready to start, it can go ahead and access the field to be able to do things that require accessing additional objects provided by the broader context in which the thread is running. So in this case, we could pass in the activity, and then if we need to access it, it's right there because it's a field within our GCD runnable class. And here's kind of what it would look like. Here's the main activity. And this is an Android thing. When someone clicks the run runnable option on the GUI, that will go ahead and create a new thread with a new GCD runnable, passing in this, which is the activity. And that, of course, will be passed into that constructor. And once we start the thread, then the run method will run, and we'll be able to get access to that activity. So that's how you pass parameters to threads. The other way to do this is to use some kind of setter getter method like approach. So here's an example where you have a different technique. This is using the inheritance version. So GCD thread extends thread. That's a different example here, a different file. In this case, we're going to have two fields, main activity and random. The way we're going to do this is we're going to have a couple of setter methods. Set activity, which sets the activity. Set random, which sets the random number generator, and so on. These are the setter methods that you can call from some enclosing context in order to set the fields. Notice the way we use what's called fluent interfaces. These are all the rage these days in object-oriented programming and functional programming. What you do is you have setter methods that return the class that they're a part of. So you do your thing, and then you return this. So in this case, set activity takes an activity and returns GCD thread. And the reason we do this is because then we can go ahead and, as you'll see in a second, make these things, chain them together when we call them. I'll talk about that in a sec. Here's the run method. Assuming that we've called these activity setter methods and random setter method, then when you call run, we'll have access to the activity. You'll have access to the random number generator, and those things can be accessed from the thread when it begins to execute. Here's what the use case would look like. Here's the callback hook that Android will invoke when you click the run thread GUI button. And as you can see, what this does is it makes a new GCD thread, it sets the activity, and it sets the random number generator. And notice how cool this is because it's fluent, right? So we say new GCD thread, that makes a thread, dot set activity, which then returns the thread, set random, which returns the thread. So we kind of chain all these things together, and we end up initializing this thread. And then when we start the thread, that run hook method will be invoked, and the wheels begin to turn. I show this to you because it's extremely popular these days. And it's actually, depending on how you use it, you can actually implement various Gang of 4 patterns, like the builder pattern can be implemented using a technique not unlike this. OK, so that is the end of the Java Threads overview part 1. You know just about enough to do the assignment. The only thing we haven't really covered yet is join, and we will do that in subsequent classes.